In the previous video, we learned what antiderivatives are and found that to find the general solution of an antiderivative, we have to first take the antiderivative of what we're given and then add a plus c at the end. One method for finding an antiderivative is called the power rule for antiderivatives. Let's look at how we can use the power rule for antiderivatives. Let's say if we have f prime of x is equal to x. The power rule for antiderivatives says I need to take the exponent on my x, add 1 to it, and then multiply that x with the reciprocal of the new exponent. Right now, I don't have an exponent written on my x, so that exponent would be a 1. So to find the antiderivative, f of x, I would have to first add 1 to my exponent, which would make it a 2, and then at the same time, I can divide by that new exponent. This would simplify to 1/2 times x squared. Now that I've found the antiderivative of x, I can add a c to it to complete the general solution. Let's say if we have f prime of x is equal to x to the 5th. If you think you know how to do this, go ahead and pause the video and work this out on your own. I'll wait. Oh good, you're back. So to find the antiderivative of f prime of x, I would have to use the power rule for antiderivatives. I need to first add 1 to my exponent and then multiply this x value with the reciprocal of the new exponent. This would give us 1/6 x to the 6th power. Now that I found the antiderivative of the x to the 5th term, I can add plus c to finish the general solution. Let's say if we're given f prime of x is equal to the square root of x. Go ahead and pause the video and try to figure out this on your own. And we're back. In order to use the power rule for antiderivatives, I'd first need to rewrite this root x using a rational exponent. So now the antiderivative of f prime of x, I first need to add 1 to the exponent, and then I can multiply my x term with the reciprocal of that new exponent. In the last two examples, I didn't write the plus c in my first step of finding the antiderivative. Sometimes it's better to write in the plus c the very first time you find the antiderivative, just so that you don't forget it. 1/2 plus 1 is equal to 3/2. So this would give us 1/3/2 x raised to the 3/2 plus c. We can do one more thing to simplify this. Dividing by 3/2 is the same thing as multiplying by 2/3. You're probably getting the hang of this by now. So here's 4 problems I want you to try on your own. Pause the video and figure these out. This first problem is a polynomial. Polynomials are really easy to find the antiderivative. All we need to do is apply the power rule for antiderivatives to each individual term. F of x would equal to 8 divided by the exponent after we add 1 to it. So our exponent is 9, and 9 plus 1 is 10. And then we'd have x to the 10th power. The next term has a 6, and then if we add 1 to that exponent, it would become a 3. So we put 3 in the denominator. And then we multiply that with x raised to the 3rd power. We have a constant term of 5, so if you have a constant term, just multiply an x with it, and then write in your plus c at the end. This would simplify to 4/5 x to the 10th power, plus 2 x to the 3rd power, plus 5x plus c. Here's another polynomial, 5x cubed minus 3x plus 7. So f of x would be 5, and then if we add 1 to the exponent, you have a 4 in the denominator, times x to the 4th power, minus 3. If you add 1 to the exponent, you'd have a 2. So put 2 in the denominator, and then x squared. We have a constant of 7, so just stick an x next to that, and then write your plus c at the end. This one might be a little bit more tricky. We can't use the power rule for antiderivatives for this. This one involves trig functions. Have a look at your reference section where you have the derivatives of trig functions written. The antiderivative of sine is cosine, but we have to flip a positive to a negative or a negative to a positive when we do this. Since we began with a positive sine of x, the antiderivative would be negative cosine of x. And now if you just look down the list of trig functions and look for the one who has a derivative of secant squared, you'll see that tan of x has a derivative of secant squared. That means the antiderivative of secant squared is tan of x. Now that we've found the antiderivative of these two terms, we can add a plus c at the end. F prime of x is equal to -2 over x cubed. We can actually use the power rule for antiderivatives for this if we rewrite this as x with a negative exponent. That would be -2 x to the -3rd power. So now to find the antiderivative of this, we start with our -2 coefficient, and we have to divide that by the new exponent that we'll have after we add 1 to it. Our original exponent was a -3, so -3 plus 1 would be -2. We multiply this with x raised to the -2 power. Now we can just add a plus c at the end. -2 divided by -2 is just 1. And then if we have a negative exponent, we can write that into the denominator with a positive exponent. Each of the answers to the examples in this video had a plus c in their answer. That means that we were finding the general solution. In the next video, we'll look at how we can find the particular solution using antiderivatives.